I forgot to talk about this before I turned the video on, but I'll say it anyway. So I just wrote down a few learning targets. I'm continuing the first one in terms of understanding why systems are important. I'm hoping that over the next few lectures, you're going to start to realize how important they are. But I'll just remind you, yesterday we talked about life is never so simple that you only have one unknown. Life has many unknowns, right? And so to solve something that has two unknowns, you have to have two equations, right? That's why we're learning how to deal with two equations and solve for the unknowns, right? So it's a powerful, powerful thing. Number two, I can list the 3 ways to solve linear systems. There are actually more than 3 ways. There's lots of ways, but we will be focusing this year on 3 ways in particular. And the last one was I can use substitution, which is the second method, the second of the 3 ways. So, first of all, there are 3 ways. So 3 ways to solve systems, at least that we're going to learn. The first one is by graphing, which you already know. You graph them. You graph the 2 equations on the graph, on the same graph, and when you are done, you should have a place where they cross, right? Unless they're parallel, right? If they're parallel, they'll never cross. So you'd have to say there's no solution. Or what if they coincide? You guys know the word for coincide? You know what that means? Think about it. Look, they're the same line. This is the coolest thing. Watch this. If I had y equals 2x plus 3, and I wrote this, 2y is equal to 4x plus 6. Do you notice anything about these two?
Yeah, it's multiplied by 2.
All I did is I multiplied this one by 2. If I graphed this one, it would be exactly the same line as this. Right? But I could make this, Bo, are you listening, buddy, or are you talking to her?
I'm listening.
Okay. So I could write this so that it doesn't look like it. I could write it in standard form. I could subtract the x, right? I could subtract 4x from both sides. I got negative 4x plus 2y equals 6. And then I can multiply everything by negative 1 to make that positive 4x minus 2y is equal to negative 6. And now you'd never know that those were exactly the same line. But that line and that line are exactly the same thing, right? They're exactly the same thing. So those are when lines coincide. So there's going to be an infinite number of solutions, right, if they coincide. Do you agree with me? Both lines are the same line. Therefore, they both share all the same points. Does that make sense? You know what I mean? Or if they're parallel, they never share the same points. Or if they're not parallel, then they share 1 point. Does that make sense? You get it? Okay. And then the last thing is I can use substitution. Okay, so there's 3 ways to solve systems. One is by graphing. And have you guys noticed how graphing is not always going to be easy?
Mm-hmm. No, it's hard because if you have like what we're talking about, if it like keeps on going, you have to keep on graphing it, keep on graphing it.
Right. And life is not that neat and orderly. You know what I'm saying? It never. I mean, most real life situations, you're not going to have things land right on the corner of a grid, so that it's -2, +3, right? It's never going to be that. It's going to be -2.73941, comma, +4.62135, right? You know what I'm saying? It's never going to be exactly a whole number. I mean, maybe not never, but it's unlikely in real life. Okay? So the first one is by graphing. The second one is by substitution. What does substitution mean? Anybody know? Can somebody give me a definition for substitution? Or an example or anything? Tom?
Like to replace?
Yeah, to replace, right? To replace something with something else, right? Yeah. Okay, and the third way is elimination. All right? Those are the 3 ways we're going to study. You already know the graphing way. So today we're going to focus on the substitution. all right? And the difference with between 2 and 3 versus 1 is that 1 is graphing, 2 and 3 are the algebraic ways to do it. And it's much simpler to use the algebraic to solve systems. You can do them very, very quickly. Sometimes they're hard and they take a little focus and a little time, but they'll be easier than using the graphing method, right? And more accurate, quite honestly. Okay? So you take your notes, dude? Caleb?
Yeah, I'm taking notes.
All right, so we're going to focus on substitution. All right, so I told you that if I have 2 unknowns, I have to have 2 equations. Do you guys totally believe me on that or not?
Yeah.
You too? Okay, so I'll give you an example. Y is equal to 2x minus 4. I need one more equation so that I can totally solve and know exactly what x and y is. All right, I'll write it up here. Y is equal to 10. Y is equal to 10. Is that an equation?
No. Yes.
Yeah, it is. Y equals 10 is an equation, right?
Because it has an equal sign.
Because it has an equal sign, right? So what I'm going to do is I'm going to use substitution. Now, with substitution, this is the first thing you look for. Look for. This is what you're looking for. At least one of the equations. One equation must start with x equals or y equals. Okay? You got to have an x equals or a y equals. You can't have x plus 2y equals something. You've got to have x equals. Do I have that or y equals? Do I have that in one of these equations? I have it in both of them, right? So it doesn't matter. I could choose either one. I'm going to choose. So that's the first step. The second step is circle what x equals or y equals. All right? So I'm not going to circle both of them. I'm just going to circle one of them. I'm going to circle the simpler one, right? In this case, since they both have y equals, wouldn't you guys agree with me y equals 10 is the simplest one? I'm going to circle 10. Okay? 10. It says y equals 10. That means y is 10. It's exactly the same thing as 10. Y is 10. Therefore, I'm going to circle, I'm going to go to the other equation, and I'm going to circle the y. Okay? You guys see this? So I'm going to circle the y. And so now what I'm going to do is I'm going to draw a little arrow down here from the 10 to the y, and I'm going to replace that y with that 10. So here's what I get. 10 is equal to 2x minus 4. How many unknowns do I now have in my equation? 1. I went from 2 unknowns to 1 unknown just by substituting. It's a powerful, powerful method. All right? So now can I solve for x? Easily, because I have 1 unknown, 1 equation. That's all I need. So I'm going to add 4. Add 4. I've got 6. Oops, guys, not 6. Sorry. I have 14 equals 2x. And I'm going to divide by 2, and I get x is equal to 7. All right. So I know as x is 7. Do I know what y is?
Yes?
Yes, y is 10. So y is 10. So I could do this. I could have that as my answer. Or I could write it as a coordinate point, which is x comma y. So I could write it as this. 7 comma 10. And put that in a box. Those are both correct answers. Does that make sense? You writing this down in your notes?
Sí, señor.
Okay. So that's the first one. That was really easy though, right? Let's see if we can do one that's slightly harder now. Can I erase this?
Wait, yeah.
I can? Yep. Okay. Now let's do one that's just a wee bit harder. So wait, so let's look at our process. At least one equation must equal x or equals or y equals. Circle what x equals or y equals. And then substitute, right? Substitute it into the other equation. And then you have one unknown, and you can solve it. You know? Okay. So for solve for unknown, and there's one more, but you'll see that in a second as we do this other one. So here, let's do y equals 3x plus 2. Y equals 3x plus 2. And x plus 2y equals 11. X plus 2y equals 11. Okay? All right. So what's my first step? I'm looking for, I have to have at least one of the equations that says x equals or y equals. Do I have that?
Yeah.
Okay. But what are you up to, buddy?
Nothing,
So,
I'm just looking for something.
you're just so busy. All right. So y is equal to 3x plus 2. So I'm going to circle it. That's exactly what y equals. That is what y is. It's 3x plus 2. So I'm going to circle the y. Harrison, you writing this down in your notes? Can I see? Just want to be sure. Okay, good. All right. So I'm going to circle the y. Am I going to circle the 2y or just the y? What?
2y.
But this says this is y. I'm only circling the y, not the 2. And that, I'm going to put a little, right? And I'm going to put this down into this. And now I'm going to substitute this into the y, but I've got to keep that 2 as 2 parentheses. That's 2 times, right? So I've got x plus 2 parentheses, 3x plus 2, right, equals 11. Does everybody see what I did?
Yeah, that makes sense.
Make sense to you? Who's confused? Anybody? It's fine.
No, I get it.
You get it? All I did was I'm trying to create the second equation so that I don't have 2 unknowns. I'm trying to get rid of that second y. That y.
It's like the y has the 3x plus 2 inside of it.
Yeah, exactly. So now all I have is x's as my unknowns, right? And I have one equation for x's. I can solve for x. So here I go. I go x plus, I'm going to use my distributive property. I've got 6x plus 4 is equal to 11. And I am going to, what would I do first? Gavin, what would you do?
You'd subtract the 4.
Okay, I'm going to subtract the 4.
And then you add, wait, no, shouldn't you put the x's together first?
What's 11 minus 4?
7.
7, okay.
Wait, shouldn't you put the x's
And then
together?
7x equals 7.
Well, shouldn't I subtract x from both of these?
No, you add it.
Oh, they're on the same side. You guys are getting this now, right? That's good. Right? If I did that, I would be subtracting 2 x's from this side and nothing from this side. These are on the same side. I just combine them, right?
Yeah,
I have
so
1
it
x,
means
1
7x.
apple, and plus 6 apples means I have 7 apples. 7x is equal to 7. Divide by 7, divide by 7, x is equal to 1.
Wait,
right?
isn't 0x technically the same thing as 1x?
No. 0x
Wouldn't that mean
is
that x
equal
is
to 0 times x. What is something worth when 0 is multiplied times x? 0. So that's always 0. But 1x is equal to 1 times x, which is equal to 1x, or just x, right? Either one. Right? Big difference, big difference. So when you don't see a number in front of a variable, there is one. It's always a 1. Literally, 1.
But
Okay?
if you see a 0 in front of it, then
If you see a 0 in front of it, then it's a 0, right? But if you don't, if you see nothing in front of it, it's a 1. That make sense? All right. So I know my x is 1. But remember, with a systems of equations, I'm actually supposed to you're supposed to tell me what is the point. I need to know, what am I missing? I need to know what? I know my x equals 1. What else do I need to know? I need to know the y. So I can go back to either of these two equations, and I can substitute the 1 into the x in either of these two equations, which one though would be the easiest one to use? Or which one? This equation or this equation? The first one or the second one?
The first one?
I think the first one, personally. Because aren't I looking, I want to know what y equals, right? And the first one says y equals, right? I don't have to move things around to get it to say y equals. It just says y equals. That's what I want to know. What does y equal? So I just plug in my 1 for that. So I'm going to say y equals 3x plus 2. So y is equal to 3 times 1 plus 2. So y is equal to 3 plus 2, which is y is equal to 5. There's my answer. So I could say y equals 5 here, or I could do 1 comma 5 as a coordinate point and put it in a box. Make sense? You guys get it? It's really pretty straightforward. But I think right now, instead of solving more, I just want to practice substituting in. Is that okay? So we set them up. I'm going to just do a few just to see if you guys can help me set them up. And this will always work. It'll always work. It's not always easy. Because what if you ended up substituting in a fraction or lots of fractions, right? That would be kind of tricky. So it's not always the easiest method. Sometimes the elimination would be an easier method, but we don't know that yet. All right, what if I gave you this? Y is equal to 4x minus 6 and 2x minus 3y is equal to 12. What would I do? Okay, got it.
You'd substitute the y for the
I got to circle what?
y.
What am I circling?
The y?
This?
No,
I'm circling what y equals.
Yeah, the y.
Right, this is what y equals. So I circle that. Okay, go ahead. Oh, I see. And then I circle this y?
Yeah.
Just that way, not the -3. And I've got a little arrow going to that, so I know what I'm doing. Now what? Harrison.
Wait, so then
Now what do I do?
Oh yeah, so then you do 2x minus so 2x minus 3 then
So what it goes here, this is really
plus
important, guys.
4x.
Taylor, look, make sure you're watching this. Are you writing stuff down?
Yeah, look at
Okay.
Oh, parentheses.
Ah,
4x.
parentheses, because that's a blob. That's a big thing, right? It's more than one term.
So 4x minus 6.
4x minus 6 equals 12. Now, notice all I have left are x's. So I could solve this, right? It's pretty easy. I'm not going to go there. I'm not going to finish. I'm wanting to just practice a couple setting ups before I give you the homework. All right.
Very. So don't see.
Y equals negative 2x minus 3. And then I've got 2x minus 4 y equals 7. All right, how would I do this? Somebody else. Erica, help me.
Okay. You circle negative 2x
Okay.
minus 3, circle the y with
Okay.
the arrow,
Yep.
and then you do 2x minus 4 parentheses, negative 2x minus 3 parentheses equals 7.
You got it. And then let's go one step further. Let's get rid of the parentheses.
So
You
then
do
you
just-
do the top B where you do negative 4 times negative 2x and
Okay, so what do I get? Negative 4 times negative 2x is?
it's a positive 8.
All right, then what do I get for this one?
And then it's a positive
Is it positive or negative?
12. Positive. There's 2 negatives and positive.
Well, but there's only one negative there. What do you mean, 2 negatives?
Negative 8 negative?
Oh, you guys are good. I just wanted to be sure. Okay, equals 7. So great. And now we can solve it, and we could then figure out what it is, right? It might end up being a fraction. And if it is, then you got to plug in a fraction up here, right? It could be, right? That's where the substitution method sometimes can be a little labor intensive if your answer to one of them is a complicated fraction. What if it was, 3/17, right? And you have to plug in 3/17 into this equation. It'd be kind of a mess, but
It was.
we could do it, but it would be kind of a mess. But you're probably not going to get those from me, so The main thing is that you understand the process. Does that make sense? Okay, so that's it. Just to 5. You guys feel like you get it? Awesome. It's actually pretty easy, and it's pretty straightforward. You know those? I'm going to just show you something really quickly. Remember those word problems that most people didn't like? That started like this? They started like this, right? It said, the sum of two numbers is 25. Remember that? What are the two numbers? The way I taught you. What were the two numbers? The first one was x. The sum of two numbers is 25.
X and x plus 1.
And the other one was the total, 25 minus x, whatever's left over. Remember that? That's hard to get your head around. Do you agree with me? I mean, I find every time I teach that, it takes like weeks before kids actually get it. Oh yeah, I'll remember that. Watch this. The sum of two numbers. What if I made an x and a y my two numbers? X plus y equals 25. How many people find that really quite simple? Isn't that pretty easy? There's one number, there's the other. Sum means I add them. It's equal to 25. Isn't that more intuitively easy to understand?
Yes.
Right? Let's see what y would be. I know x is one of them. Let's see what y would be. Let's subtract x from both sides. Y is what? 25 minus x, which is what I told you before, x and 25 minus x, right? But with this method, with systems of equations, you don't have to worry about memorizing this. You just immediately know, oh, sum of two numbers is 25. So x plus 7 is 25. Okay, x plus y is 25. Easy, right? See what I'm saying? So a lot of stuff becomes easier once you understand systems of equations. So it's really powerful. No way. Okay, that's it for the lecture.
Bye-bye.